So today we are doing counting. Okay, maybe it's easier than the previous lesson. Okay, so let's work on this. Okay, so everybody know how to do the first problem, guess. Okay, so between two cities, right, and they have city A and the city B. Okay, there are 3 direct highways and right 5. There are 3 direct highways. Okay, I'm going to draw the picture a little bit better. Okay, how many cities here we are considering? We have A and yeah, right. So between city and B, there are 3 direct highways. 3 direct highways. Okay, and 5 direct railroads. Okay, 5 direct railroads. So I'm going to use the different colors. 1, 2, 3, 4, 5. Okay, so they just add them together, right? How many ways one can travel from city A to the B? Just choose one of them. So it would be 3 plus 5, which is going to be 8. 8 ways, right? That's the easy part. Okay, just add them together. The second problem, okay, we have 3 cities now. City A, city B, and city C. Okay. So let's see. From city A, between city A and B, there are 2 direct highways. Okay. Right. Okay. And from between city B and city C, there are 3 different railroads. Okay. 3 different. So 1, 2, 3. Okay. Now the question is, how many different ways? Okay. You can, yeah, how many different ways? Okay. So how many different ways you can travel from A to C? Okay. Well, you can count in the following. Okay. So that's, if you begin with this, right, then you have 3 choices. Right, and then you begin with the other road. You also have 3 choices after you pass the city. After you pass the city B, okay, right? This is 1, and here 2, and here 1, 2, 3. So we usually solve this problem using the product. Okay, so total there are 2 times 3 and 6 ways. Okay. Now, yeah, this is if you in each step, if you have in first step you have 2 choices, second step you have 3 choices, then the total number of choices, total numbers of ways to go through, right, is going to be 2 times 3. You can also count. Why is it 2 here? The reason is for each, okay. For each highway from A to B, right, you have 3 choices. Once you fix the first road from A to B, okay, you have 3 choices. Then you have, if you fix the road 2 from A to B, you have 3 choices. So total here is 3 plus 3. But actually 3 plus 3 is 2 times 3, okay? That's a 6. Yeah, this is how do we calculate, okay? So 2 times, depends on how many roads from A to B, okay? This 2 depends on how many roads, is the number of the roads from A to B. For each road, you have 3 railways from B to C. That's why you use a product, okay? Guys, please, that's the reason we the 6 is going to be 3 plus 3, right? But they also can be considered as 2 times 3. It's a multiplication. The 2 is because they have 2 factors of 3 here. Okay. All right, so take a look at the next problem. That's a slightly different new problem. All right, what we're going to do here is a 3 identical squares, okay? And each square and painted in these 3 different colors: white, yellow, and green. Okay, so yellow and the white and the green. Okay, so there are how many ways to paint them? How many ways to paint it? Okay. So well, in other words, if you put them in a row, how many different patterns you are going to get? How many different patterns you are going to get? Okay. Some students say 9. Some students say, everybody get 9, huh? Then we have a different voice, such like a Kevin. Okay, and okay, but Kevin, don't type too many 6. Does not mean you can get, yeah, right? Does not guarantee you're right. Okay. Okay. So how do you do this? Well, we can list all of them. Okay. So you begin with the first one, like yellow. Okay. Then white, green. But you can also have a yellow, green, and the white. That's it, right? So no more. Then you begin with the white, then yellow, green, white, green, yellow. Then you begin with the green, then green, yellow, white, green, white, yellow. So total there will be 6. Okay, total there will be 6. So this is you can express in the formula, right? You have each time you get 2, right? 2 and 2 and 2. Add them together, you get 3 times 2, okay? Which is going to be 6. Okay. You can also view it as like a, in each row, right? Yeah. So that's 2 times, yeah. So 3 times 2 is 6. That's all. How do we? Yeah. You can use a product. Okay. Yeah. 3 times 2 equals 6. Because how do you get 3 times 6? 3 times 2, because you have in each column you have 2 possibilities there. Okay. Right. All right. So I hope next one you can do correct. 2 of us 3 flags in 3 different colors: red, white, yellow, are hanged vertically. Okay. Hand vertically. I'm going to hand this flag vertically, okay? And 2 of the 3, not all of them, okay? And how many different signals can be presented by these 2 flags? So we only have 2 flags here, but we choose, they are coming from the 3 flags, right? You have a flag 1, 2, there. Okay, let's find out. One is yellow, right? Other one is white, and then the other one is red. Okay, I don't have the red color, so let's use this color, okay? This is a slight difficult. Okay. Okay. So you're going to handle it, right? So a typical example will be, you can only have 2 flags right now. Okay, you only have 2 flags. Vertically handle that, right? So how do you solve this problem? Well, how many have we got? Okay, so you just take 2 out of 3. So in other words, you just decide which one you're going to delete, right? If you delete the red one, then you have, then you have a yellow, white, right? Then white, yellow. That's the first step. If you delete the yellow, then you have a red, white, white, red. If you delete the white, you have a red, yellow, yellow, red. Okay, so that's why you have a total have a 6. Okay, so this group without red, this group without yellow, right? Right, and this group without white. Okay, so that's why you total you have a 4 times 3. Right? How many of them? 4 times 3. So there are 4 times. Okay. This is how many different signals you can get. Okay, each group, yeah. So our idea is you pick up 2 out of 3. Okay. Each time, yeah, then you switch the order. So you get 4. So it's 4, 4, and 4. Okay. And add them together is going to be 3 times 4, which is going to be 12. Right? Hold on, yeah. So let's see. No, sorry. 3, 3, so, okay, so it's going to be the pattern. It's not 4, it's HR times 2, yeah. So I can't, yeah, this is one group, another 4 letters. 4, okay. So you get 3 2s, so it's still being 6. Yeah. Okay. Yeah. So the signal, represented by 2 vertical flags, right? How many different signals you can get in the first group, right? 2 signals. So a total 3 2s. Okay. RWWR is not different. So because the order is different. Suppose you handle those 2 flags outside the window, right? And you can tell your friends, hey, yellow first, white second, below. That means my father is not at home, right? just kidding, right? But that's true, right? And the white on the top, yellow at the bottom, that means my father is at home,
So, Shen, I have a question.
Yes.
Okay, for this, in this problem, you mean that 2 of 3 flags will select different colors from red, white, and yellow. So when these 2 select the colors, how about the third one? You have any limitation for the color of the third?
No, the third one just put away. We just say this is just in the box of these flags. You just pick up 2. Only 2 show up on the on this side. Okay, only 2 shows up. Okay, you
okay.
Don't. The other one you don't see that. It's hiding in the box.
I see. So for I'm asking this question because, for example, if the first one is yellow and the second one is white, this will be thought different if the first one is yellow and the third one is white. Just yellow and white, but the former is the first.
No, there was no third. Just that's the 1 and 2. The top one, the bottom one. That became hand on in the vertical order. So whatever C, the signal you see is yellow and yellow and white, white and yellow. Okay, if you do not, if you only pick up 2 flags, okay, so that's why each combination okay only have 2 different signals here. There's 3 different combinations you can get. Okay, and depends on which flag you're going to still, put in the box. You don't take it out. Okay, so that's why total anyway, you have a 6. Yeah, it's a little bit harder to understand, but this is we just want to see what is the outcome, what you can see, how many signals you can see. Okay,
I see.
Yeah, so each combination, there was 2 different signals you can see. Okay.
Okay, but if it will be no different if we select 2 of 3 legs or 2 of 4 legs or 2 of 5 legs.
Oh, 2 of, no, you cannot say 2 of flat. No, that's the difference. If I have that will be more complicated problem. If I have 5 legs flags with different colors, then the number, you have more signals you can make. So you can pick up 2 flags out of 5, okay? And then you will get total 20 different signals, okay? So yeah, if you have 5 flags in different colors, you only pick up 2 each time to hang on the wall, and then you can get 2 times 5. You have 4 times actually. Yeah, that will be 4 times 5, 20. Okay, but that's more complicated. Yeah, we probably deal with this later. Okay, so here's a similar questions. 3 flags are selected from a set of 4 flags, 4 different colors: red, yellow, blue, and black. Okay, and then the question is how to count them, and they are put in a row. Okay, they are put in a row, and how many different signals represented by those 3 flags. Okay. This is a little bit easy. If I only select 2 flags out of 4, it's more complicated. Okay, we have to find some formulas. But if I just eliminate 1 flag each time to get 3 flags, it'll be a little bit easier. Okay, so you can eliminate the flag. You can eliminate. We have a red, yellow, blue. Okay, sorry, blue, black. Okay. So I have to use that. So it depends. If we eliminate the first one, red one, then you have white, black, blue, black. Okay, those flags. The question is how many you can get each time. If you eliminate the yellow one, then you have red, blue, black. Okay, then if you eliminate the blue one, then you have a red, yellow, black. So total you have 4 different groups. Okay, 4 different groups. If you can figure it out, then you permutate those 3 flags. Question is how many of you can get. I think we did already did similar problems. The number 2 probably, yeah, number 3. If you have 3 flags in 3 different colors, how many different ways you can, right? You can put them in a row. Okay, so total we get 6. So then there will be 6 combinations here, and then have a 6 here, have a 6 here, have a 6 here. Okay. Okay, so total you have 4 times 6. Okay, so total is a 4 times 6. Yeah, 4 times 6. Okay, so you will get 4 times 6 as a 24. Okay, so the way we do it, you can write 6 is actually, how to get 6 is 3 times 2. Okay, I remember that. How do we get 3 times 3? How do we get 6? And this is getting more complicated, right? Look at this. Assuming you have 3 flags in 3 different colors, putting in a row, how many of them you can get, right? How many different combinations you can get, right? Then you end up with 3 times 2. You have 3 2s here, okay? Then gradually you will figure out a general formula because this number 4, 6 is going to be 3 times 2. Okay, so you see like 4 times 3 times 2. Okay, this number, of course, you can add 1 here, no problem, right? Times 1. So this number is simply denoted by 2, called 4 factorial, simplified. Okay, that's a simple notation. Otherwise, you have to keep writing. Otherwise, you have to keep writing all those numbers. Okay. Yeah, let me repeat again. So each time I delete one flag, then I only have 3 flags here put in a row. Then I permutate them, and we already did it. You know, you can draw the tree for them. Then you have 6 different patterns. Okay, since you have 4 different groups here, that's 4 times 6. But how to get 6? 6 will be 3 times 2. Okay, so then you get 4 factorial here. Okay. Okay, now let's try next one. Let's try next one. David has 3 different t-shirts and 2 different short pants. How many ways can David dress up? Huh. Okay, so you have a t-shirts T1, T2, T3, and have a pants P1, P2. Okay, so when he dress up, t-shirts always on the top, pants on the bottom, right? So this is the way how to do that, right? So the question is how many combinations you can have. So most of the students just say 6, 6, 6. Okay. So yeah. So here we're going to introduce so-called product rule. Okay. If you want to use if you use a matrix, and you can say T1 combined with P1, right? And the T1 and the P2. You know, you pick up the first t-shirt, then you have 2 choices for the pants. And then you pick up a second t-shirt, then you have, you can pick up first pant and the second pant. You have 2 choices. And similarly, you have if you pick up the third t-shirt, then you have 2 combinations with the pants. Okay, total in mathematics, we call it a matrix. Okay, a matrix of combinations here. So then how many of them? How to count them? It depends, right? If you count, each row is going to be there are two elements here each row, right? And you have 3 columns, 3 times 2, total is 6. Just like I find the area, right? So 3 rows, 2 columns, 3 rows, 2 columns. So 3 times 2. Okay. So we call the product rule here. If we have you have 3 choices for the t-shirt and the 2 choices for the pants, then how many different combinations you can get? It's 3 times 2. Okay, remember that. Okay, that's called the product rule. If the number of choices for the first group of objects, number of choices for the second group of objects, and if you want to choose a pair of objects, then how many different pairs you can get? It's you have the product of those 2 number of options. Okay, so that's called product rule. Yeah, how do you get product rule here? If you see the picture, it's quite clear. Okay, because T1, T2, T3, you have 3 choices for t-shirt, and for each fixed choice of t-shirt, you have 2 choices for the pants. Okay, so combination have a total 6. So that means if you every day want to change your clothing, right? Different pack combination, 6 days, right? So you need 3 t-shirts, 2 pants. Okay. All right. Yeah. So our next problem is about numbers. Okay, we're doing it. How many 2-digit numbers are there? Question is how to count. Some students immediately tell me 90. Okay, the reason is you start with 10, 11, 12, all the way to 99. right? From 10 to 99, you get 99 minus 9, so it's going to be 90, right? That's the one way you can count. Right? Why minus 90? Minus 9. Why not minus 10? The common mistakes will 99 minus 10. No, because 10 is included in this set of two-digit numbers. There's another way to count, okay? Yeah, there's another, yeah, you see, I keep saying, you know, it's easy to make a mistake. Something indeed make mistakes. They give me 89, not 90. Okay, the reason why minus 9 is because you can have 1, 2, 3, right? All the way to 9, then 10, 99. So total here is 99, but this is a 9, not 10. So 99 minus 10 gives you 90, okay? You do the subtraction, okay? Then you get 90. That's clear if you draw the picture here. All right, but there's another way to view a two-digit number. Two-digit number is actually a combination of those two, right? Two digits, combination of these two digits. And for the first digit, okay, for the first digit, 10th digit, how many choices you're gonna have? You have 1, 2, 3, all the way to 9, right? For the second digit, you have 10 choices. It can be 0. Okay, so you just like similar to the T-shirt and pen problem. Okay, so now you have for the left one you have 9 choices. For the right one you have 10 choices. The combination will be 9 times 10. Okay, 9 times 10, so it's also 90. So why is 9 times 10? You can get a matrix 1, 0, okay, 1, 1, right? Each time when you choose the first digit is 1, then you have 10, right? Then you have a 2, 0, 2, 1, 2, 9, then keep going, right? And then you get another matrix. Okay, so this is a bigger matrix, as you can see. How many rows there? 9 rows. How many columns? There are 10 columns. So this is a 9 times 10 matrix. So how many total numbers inside? 9 times 10. Just like how do you just like find the area, right? So 9 times 10. That's a product that gives a total number of elements in this matrix. So we are learning matrix now, right? This is very advanced topic, yeah. See, so this is that's why we use a product instead of counting them directly. Sometimes it's much harder to count them directly, like take a difference, yeah. Take a difference again, 90, but the 90 comes from 9 times 10 too, right? So 9 times 10. So that's why we should think about a different way, okay? Another way to think about this is you're going to, if you write down two-digit number, it involves 2 steps. Step 1, write down the 10th digit. Step 2, write down the units digit, right? So how many ways to write down 10th digit? 9, because 0 cannot be the 10th digit. How many ways to write down 10 units digit? 10. So this procedure, writing on two-digit number involves 2 steps. Step 1, step 2. Each step there was a choice, number of choices. 9 choices, 10 choices. So the total number of ways to write down the two-digit numbers will be 9 times 10. Okay, that's called the product rule in the counting. Okay, this is called the product rule in the counting. I'm going to write down that product rule in counting. Okay, just product. Yeah, step 1, step 2. Each step you figure out how many options. Okay, then multiply them out. All right, so let's take a look at the next one. How many two-digit even numbers there. Oh, are there. Even number. Okay, so if you apply the product rule, then you can solve the problem. The digits. Okay. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And then let's circle the even one. Even. Okay, those are the even numbers. Okay. How many two-digit even numbers? Okay, so how do you write down a two-digit number? The two steps, right? Write down the tens digit, write down the units digit. Write down the units digit, okay? So a number is even, is only determined by the units digit, right? So for first step, how many choices? First step, you have 1, 2, 3, all the way to 9, okay? Cannot be 0. The second one, you can only pick up even numbers. 0, 2, 4, 6, 8. How many of them there? And here you have a 9. Here you have a 5. So product rule tells you that should be the product, 45. So there are 45 such a number then. Now you can also list them as a matrix, like 1, 0, 1, 2, 1, 4, 1, 6, 1, 8. Then 2, 0, 2, right? 26, 28, and keep it going. And then 9, 0, 9, 2, 9, 4, 9, 6, 9, 8. So you have such a big matrix you're going to get. Okay. How many rows there? 9 rows. How many columns? 5 columns. Total, there are 9 times 5 different numbers there. Got it? This is called the product rule. Okay. Yeah. Okay. The reason it's product rule is coming from the matrix. If you look at the matrix, but you don't need to write on the matrix if you know the product, right? But the product rule is coming from the matrix. You have so many rows, so many columns there. When you count the total number of the numbers inside the matrix, you have the number of the rows times the number of the columns. Okay. Right? Why not? Why should it be the product? Because each time you have a right, you have a 4, I have 5, 5, 5. How many 5 there? 9 5 there. That's why. That's product. Okay. So that's the so-called technique, counting techniques. Let me explain to you again. Counting techniques. Counting techniques. Step 1, you have A choices. Step 2, you have B choices. How many ways to complete step 1 and step 2 together? The product. Okay. So the product. So the above problems. Okay. So if you write down 2-digit number, right? In step 1, yeah, let me explain to you this. Step 1, you know, you have you write down the tens digit, right? Yeah, to write a 2-digit number. Right? Step 1, okay? You have to write down the units, tens digit, right? And the step 2, you have to write down a units digit. So if you only consider even numbers, then you have you know, you can count how many even digits, right? Okay, so that's why how do you get, you know, if you write down 2-digit even numbers, right? Then if I put the even here, then I have to put the even here, okay? Then you have, you know, then you have, let me repeat again, then you here, you have a 1, 2, 3, all the way to 9, and here you only have a 0, 2, 4, 6, 8, okay? So that's why, and then the product, the numbers of ways to write down a 2-digit number, 2-digit even numbers is going to be the product of this from the numbers from each step. Okay. So then you know, I already explained to you that product. Okay. All right. So let's take a look at the next problem. Okay. Select the 2 digits from 183 to form a 2-digit numbers. Okay. How many different 2-digit numbers one can get? How many 2-digit numbers? Okay. Eric, you answered the question too quickly. Come on, do you understand the problem? Alex says yes. Okay, I'm going to select yes. Okay, good. Okay, so here you have a 3. Okay, right? How many different 2-digit numbers, right? So you write down a 2-digit number, right? I'm going to write down a 2-digit number. Okay, and no, it's different from the problems as before. Okay, so first of all, how many choices for the 10th digit? 183, right? Do you agree, right? How many choices for the 10th digit? First step. Second step, how many choices for the units digit? Still, right? It's going to be 183. It's not like an object. Once you use that, it's gone. The digits you can use the over again. So total, you have 3 times 3. There'll be 9. There'll be 9 different 2-digit numbers here. Okay, so answer is 3 times 3, which is 9. I can list all of them. I can show you. 1, 1, 1, 8, 1, 3, right? 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 8 to 1, 8, 8, 8, 3, 3, 1, 3, 8, 3, 3, 9. Well, select 2 digits, yeah, to form. So here, when we talk about digits by default, okay, this is not like an object, you know, you have like a puzzle, you have already pieces, you cannot reuse it, okay? So the digits can be used, yeah, it's abstract concept, okay? So this is going to be 9, I maybe have to, maybe I should use, yeah, using 2 digits. Once you use it, you can to write 2-digit numbers. Yeah, maybe my wording is not perfect yet. So use using 2 digits, right? All the 2-digit numbers, the digits from 183. Right. All right. Anyway, so if you understand the problem correctly, then you should be able to get answer. Okay. It's not like a 3 objects. So once you use it, you cannot use again. Right. Okay. How about this? 3 numbers are selected from 50549. Okay, to form a 3-digit numbers. How many numbers one can get? Okay, so for example, you know, 504, okay, or 554, right, or 444. Yeah, if I put to say was replacement, then probably it's okay, right? Without replacement, cannot use it over and over again. Right? How many? Captain says 48. Is such a big number? 48. All right, so let's do this. Okay, this is a three-step problem. Step one, right? Three-step problem. The hundredth unit. How many choices for the hundredth digit? 3. Okay, 3. Why? Because it's you can only use these 3 numbers. Okay, you can only use these 3 numbers. And the step 2, okay, you can pick up any of those 4 digits. Okay, you have 4 choices. Step 3, right? This is for the units digit. Okay, yeah, tens digit, units digit. You only also have 4 choices. Okay. So now what you can get? Okay. So you get to form a 3-digit number, how many numbers you can get? So total, yeah. Total, you're going to get 3 times 4 times 4, 48. Okay. You get 48 different numbers. Okay. 48 different numbers you can get. Okay. Now, if I modify the problem, say all the digits are different, there'll be different, the totally different answers. Okay. Well, we're not going, yeah, suppose you modify this. Okay. If I ask you to make sure 3-digit numbers, all the 3 digits, what happens? Yeah. Well, if 3 digits are different, then it will be more complicated. Okay. It's not easy to solve. Okay. So that means the digits cannot be repeated. Digits cannot be repeated. Okay. How do you do this? Well, first of all, the hundredth digit, right? And this is a tens digit. This is a units digit. Let's figure it out, okay? So this time you can view those digits and like an object. You have an object, okay? 1, 0, 5, 4. You write down these 4 digits on the card. You just pick up the card and put it here. So for the hundredth digit, step 1, right? You can only pick up one of the 3 cards, so it's 3 choices, right? Got it? The number of choices, okay? But for the 10th digit, you already one of them is gone, so 3 cards left. So you have 3 choices, right? Then 2 cards are gone, 2 cards left. So for the units digit, they only have 2 cards you can choose. So the answer will be 3 times 3 times 2. That's going to be 12. No, 12, 18, right? Hold on, let me check. Okay, so how many of them? 3 times 3 times 2, 18. 18, not 24. None of these divided by 2, okay? 18. Okay, 18. All right, so let's check the next one. Just do one more problem. and we're getting done. Okay, so it's a little bit difficult. Yeah. So three digits select from 1, 2, 3, 4 to form a 3-digit number. How many numbers one can obtain? Now repeat it again. All right. So you write down the hundredth digit, units, tenth digit, units digit. Tenth digit, units digit, right? And so the digits can be used over and over again. Right? The digits can be used over and over again. Okay. So this is so then the answer will be right. 3 digits select. Okay. And we do not assume that the digits are different. So then how many times? Each time we have 4 choices, 4 choices, 4 choices. Okay. Okay. So total is going to be 64. Yeah, when we say 3-digit without saying that the 3-digit number should have different digits, then they can be repeated. Okay. So then how many numbers you can get? That's you have to get 64. Okay. So let's stop here. And the idea is very simple. If we each step, if you figure out the number of ways to do, number of options, then there's a number of ways to complete all the steps will be the product of those numbers. Okay.